He was able to combine geometrical intuition with arithmetic precision, Greek pictures and Indian symbols, inspiring a new form of mathematical thinking that today we call algebra.
As a physicist, I've spent much of my life doing algebra, and I can't overstate its importance in science. But it is a strange idea. I remember being perplexed when my math teacher first started talking about mathematics not using numbers, but with symbols like X and Y. It's an incredibly liberating idea because it allows you to solve problems without getting bogged down in messy numerical calculations.
So we have here this priceless manuscript, Kitab Al-Khwarizmi's book, and
Professor Ian Stewart has studied algebra for much of his working life. Together, we looked at an early copy of the book in which the idea really took form.
I see here, although it's written sort of in the margin, the title of the book, Al-Jabr wal-Muqabala. So that's the first time the word Al-Jabr appears.
Algebra.
Algebra, that's where our word algebra comes from. Now, what I found very early on is that he said, I discovered that people require three kinds of numbers, judur wa amwal wa adad, so roots, squares and numbers. So what is he trying to do here?
This is what we would now call x and x squared. This is quadratic equations. This really is algebra. So he's setting you up for a book about how to solve equations by algebraic methods.
Okay, now quadratic equations I thought were around and being solved long before Khwarizmi, back to Babylonian times. So, what's the big deal about this book?
It's the point of view. He treats root and square as if they're objects in their own right. They're not just some number that we're trying to find out. They're a process you apply. What Al-Khwarizmi is thinking of is square means take the root and multiply by itself. And that recipe is true whatever the root might be. If it's 5, it's 5 times 5, it's 25. If it's 3, it's 3 times 3. He's giving you a general recipe, now called an algorithm, after him.
The algorithm comes from...
It comes from... It's another word that comes from Al-Khwarizmi, yes.
Now, he talks about this procedure here on the next page. You take the number multiplying the root, and then you halve it, and then you multiply it by itself. Then you add it to the other number and take the square root. That's the algorithm, is it?
That's right, and this is where you see the difference, because previous writers on the subject would have said things like, take half of 10, which is 5, square that, which is 25, and then they do another problem, take half of 12, which is 6, square that, which is 36, and they'd run you through this same process over and over again, and it would be up to you to infer how to do it on the next problem.
But he doesn't
do that. He says, take half the root. Whatever the root is, take half the root. So half the root is an object. If the root is an object, half the root is an object.
So you don't have to have in your mind what that root stands for.
No, you get about what it stands for. When you come to square it, you just know, okay, I should square this. I don't care when. So you abandon temporarily this link with specific numbers, manipulate the new objects according to the rules that his book is explaining, and then the number that these objects represent in your particular problem will miraculously appear at the end, and you'll end up x equals 3, or whatever it is.
So how revolutionary do you regard Al-Khwarizmi's work?
He made it possible for algebra to exist as a subject in its own right, rather than as a technique for finding numbers. The least interesting bit of an algebraic calculation is when you get to the end and discover that x equals 3. It's the route you take to get there. But if it was a special route for each problem and a different route for each problem, that wouldn't be interesting either. It would just be a big mess. There's this beautiful general series of principles, and if you understand those, then you really understand algebra.
What is the true global importance of algebra? It's been used throughout the ages to solve all sorts of problems. Let the mass of the cannonball be m. Let the distance it has to travel be d. Use algebra to work out the optimum angle you have to point your cannon. That sort of knowledge wins wars. Or let's call the speed of light c, the change in mass of an atomic nucleus m, and then calculate the energy released with the following algebraic formula: E equals mc squared. Mastery of that information truly is power. Algebra has helped create the modern world. Our science is unimaginable without it. It sums up so much that was remarkable about medieval Islamic science, taking ideas from Greece and India, combining and enhancing them. Similarly, modern medicine owes a considerable debt to the work of the Islamic physicians. But I think the real story of what happened to science in the Islamic world in the 8th and 9th centuries tells us more than any single discovery. What it really tells us is about the universal truth of science itself.
I believe that the first great achievement of the medieval Islamic scientists was to prove that science isn't Islamic, or Hindu, or Hellenistic, or Jewish, Buddhist, or Christian. It cannot be claimed by any one culture. Before Islam, science was spread across the world. But the scholars of medieval Islam pieced together this giant scientific jigsaw by absorbing knowledge that had originated from far beyond their own empire's borders. This great synthesis produced not just new science, but showed for the first time that science as an enterprise transcends political borders and religious affiliations. It's a body of knowledge that benefits all humans. Now that's an idea that's as relevant and as inspiring as ever.
In the next episode, I investigate how one of the most important ideas in the world arose in the Islamic Empire. I discover how mathematics and experimentation fused together as the empire embraced a medieval industrial revolution. And in Cairo, I find out how these ideas led directly to today's world of science and technology.
And that next episode of Science in Islam is here on BBC 4 at 9 next Monday. On Wednesday, here on BBC 4, we spend an evening looking at, rather than through, the world's strongest and most famous telescopes, starting with a Sky at Night special at 8.